up is addition. Addition is just repeated succession. A plus B is equal to adding 1 to A, B times. Then we step up to multiplication, which is repeated addition. A times B is equal to adding A to itself, B times. The level above multiplication is exponentiation, which is repeated multiplication. A to the power of B is equal to A multiplied by itself, B times. But here is where things get interesting. The next operation is one many people have never even heard of: tetration. Tetration is repeated exponentiation. A tetrated to B is essentially a power tower with a height of B. It is a wildly powerful operation that generates incredibly large numbers out of nowhere. For example, 3 tetrated to 4 is a tower of 4 threes. To evaluate tetration, we always start from the very top. 3 to the power of 3 is 27. 3 to the power of 27 is already more than 7 trillion. Multiplying 3 by itself that many times results in a gigantic number with over 3 trillion digits. With just the tiny numbers 3 and 4, tetration creates values so enormous they are physically hard to imagine. But tetration doesn't always create massive numbers. 1 tetrated to any number is always just 1. Even an infinite tower of ones is still 1. Now, consider an infinite tower of the square root of 2. Surprisingly, this infinite tower converges to exactly 2. A limit exists when we tetrate a number between e to the power of negative e and e to the power of 1 over e, which is roughly the interval from 0.07 to 1.44. Since the square root of 2 is about 1.41, it falls perfectly within this range. To express even higher operations, mathematicians use Knuth's up arrow notation. A single arrow represents exponentiation. 2 arrows represent tetration. 3 arrows denote pentation. Pentation is repeated tetration. 3 pentated to 3 is equal to 3 tetrated to, well, 3 tetrated to 3. As we just saw, 3 tetrated to 3 is over 7 trillion. Therefore, 3 pentated to 3 is a tower of threes with a height of 7 trillion. One level higher is hexation, denoted by 4 arrows. 3 hexated to 3 is 3 pentated to 3 pentated to 3. This number is so vast, it literally cannot be compared to anything in the physical universe. With these mind-bending tools, we can construct the famous Graham's number. We start with G1, which is 3 hexated to 3. This is already enormous. Next is G2, which is 3 followed by G1 number of arrows and another 3. G3 uses G2 number of arrows. This snowball effect continues all the way until we reach G64, which is Graham's number. For a long time, this was the absolute largest specific integer ever used in a serious mathematical proof.